multiplication of matrices. So there is a condition like in addition, two matrices can be added if they have same order. But for multiplication, it is not necessary to have same order. But if suppose A matrix is of order m by n, m rows, n columns, then matrix B must have n rows. So number of columns of matrix A should be equal to the number of rows of matrix B. Then only we can multiply these two numbers. Just see this number and this number should be same. Otherwise, we cannot multiply. Is when we are multiplying AB for finding AB, A into B. How we will find? I will tell you. But first we have to check for finding AB, number of columns of A matrix must be equal to the number of rows of matrix D. Okay, then only we can multiply first of all. Now, how to multiply is B. So let us take an example of 3 by 3 matrix. Suppose A into B, we have to multiply A into B. And A is A11, A12, A13. First row, A21, A22, A23, A31, A32, and A33. One more thing I'll tell you, I'll study in properties of a matrices. AB, it is not commutative. AB is not equal to B. You change the order, it will not equal. Okay, this we will study later on. So for multiplying AB, we have to check the columns of A. So here we are taking same order, so there is no issue. So B11, B12, B13, B21, B22, B23, B31, B32, and B33. So here this is column 1, column 2, column 3, and its rows we will take R1, first row, second row, and third row. So first row of first matrix will be multiplied by, how we will multiply, I will tell you. First you should make the first row by using first row. The first row will be multiplied with first column. And what will be the multiplication type? It will be the sum of the product of their corresponding elements. Sum of their corresponding product of sum of the product of their corresponding elements. R1 will multiply with column C1. Then first row will multiply with the second column of second matrix, and then first row will multiply with third column. Okay, it will give the first row. Then second row will multiply with first column. Second row will multiply with second column, and second row will multiply with third column. Similarly, third row will multiply with first column. Third row will multiply with second column, and third row will multiply with third column. It is just for remembering. So you will not find like this writing anywhere. So first row, how we will multiply first row with first column. This is our, now we will multiply first row. This first row will be multiplied with first column to get first element only, first element of the product matrix of the result. So first row will multiply with first column. How? Corresponding elements means A11 will multiply with B11, A11 into B11, okay, plus A12, A12, A12 will multiply with B21, A12 into B21 plus, then plus A13 into B31. This whole multiplication and with the sum will give you first element, only first element. Okay. Then you will multiply first row with second column. First row with second column. Now you will multiply first row with second column in the similar way. How? A11, is it visible? A11, A11 to, this is second, there is a gap because there is no place, that's why I have written so. This is one element, first element, do not write in bracket just for making you understand. A11 is multiply with B12 now, B12 plus similarly A12 second row with second, first row with second column B22, and similarly A13 will multiply with B30, 32, and so on. Then you will get the third element. I think you understood. Then second time, like for second row, one more element is left that you are, I think you understood. Now third time we will take the first row with this column. So we will get the third element of the first row. Understood? Then we will start second row. Now we will start from second row with first column. Second row with first column. Second row, first column. A21 with B11 plus A22 with B21, then A23 with B32, B31, sorry, first B31. So first element will come. Then first row, second column, A21, second row, second row, second column, A21, B12 plus A22, B22, and like this. I think you understood. Now when we will do some question, you can understand better. So I will take one example now. You can understand better from the example. For example, A is a matrix of elements 6, 9, 2, 3. And B is another matrix 2, 6, 0, 7, 9, 8. And one more thing, when you multiply matrix A of order m into n, multiply with matrix B of order n into p, the resultant matrix C will have order m into p. This same column or this row will be deleted, and finally you will get this one. So similarly, first check, this is how having how many rows? 2 rows and 2 columns. It has 2 rows and 3 columns. So our matrix will have 2 rows and 3 columns. So now we will multiply A into B. So A is 6, 9, 2, 3, and matrix B is 2, 6, 0, 7, 9, 8. So multiply first row with first column. 6 to the 6 into 2, 6 to the 12 plus 9 with 7. First row with this first row will multiply with first column. Their corresponding elements will be multiplied and added. So 6 to the 12, 7 9 the 63. Similarly, 6 first row, second column, 6 6 the 36 plus 8 9 the 72. Then 6 into 0, 0 plus 8 8 9 the 1. 9 9 the 81. 9 9 the 81. Then 6 0 9 8 9 the 72. Then second row, first column, 2 2 the 4 plus 3 7 the 21. The second row, first column, 2 6 the 12, 7 3 the 21. 2 into 0 0 plus 3 8 the 24. Okay. So you got how many? Well, okay, just solve this, then we will write. So this will become 60, 75, 117, 72, 25, 39, 24. Now you can see how many rows? 3 rows and 2 rows. It has 2 rows and 3 columns. Let's see, 2 rows, 2 rows and 3 columns. Okay. So hope you understood how to multiply it. Sometimes, okay. Now properties of matrix multiplication. Now we have properties of matrix properties of matrices, properties of multiplication of matrices, multiplication of matrices. Okay. First property, associative law. Associative law exists. Associative law. Okay. Associative law, because we are not changing the order. Associative law is what? A into BC. Or if we multiply AB first and then B, so they are equal. Then distributive law, distributive law, distribution of addition over multiplication. multiplication over addition. So A into B plus C will be equal to AB plus AC. Second law is also followed. It is true for multiplication of matrices. Existence of multiplicative identity. Yes. Existence of multiplicative identity. Multiplicative identity means that the matrix which when multiply with any matrix, it will not affect on that one. So it is unit matrix. So you know that when we multiply A into I unit matrix or I into A, it will be equal to A only. So I is the multiplicative. I is called the multiplicative identity for every square matrix A. Multiplicative identity for square matrix A. Now, for commutativity, it is not equal to, so it is not necessary that if A and B are two matrices and both AB and BA both exist, then it is not necessary that AB will be equal to BA. Commutativity does not exist. Not necessary. Sometimes it can be, but always not applicable. So if AB, suppose multiplication, we can find AB and BA exists. Means multiplication we are getting some result, but it is not necessary. It is not necessary that AB is equal to BA. B will not be equal to B. It can be, cannot be. Then zero matrix as the zero matrix, you know that zero, what is zero matrix? So zero matrix as the product of two non-zero matrix. Two non-zero matrix can give the zero matrix. A, B can be equal to zero. Matrix is denoted by O. And O is the zero matrix which has all elements 0, 0, 0. So these are the properties. Now we have the question, if A is equal to 1 minus 2, 3 and minus 4, 2, 5 and back and matrix B, matrix B 2, 3 first row, second row 2, 3, 4, 5 and 2, 1. Then find A and B. Question is find AB and BA. Find AB multiplication and BA. And show that A and B are not commutative. AB is not equal to BA. A and B are not commutative. As I told you, sometimes we are getting multiplication, but they are not equal. But multiplication is possible. A into B, 1 minus 2, 3 minus 4, 2, 5 will multiply with 2, 3, 4, 5, 2, 1. So it has 2 rows, 3 columns. It has 3 rows and 2 columns. So 2 by 2. You will get the matrix of 2 by 2. It's 2 rows and 2 columns. 2 by 2. So first row, first column. Can I write the answer directly? You can do the multiplication. The answer will be 0 minus 4 10 and 3. You can check the answer. Huh? And then we will find B into A. 2, 3, 4, 5, 2, 1. It has 3 rows and 2 columns. It is multiplied with 1 minus 2, 3 minus 4, 2, 5. It has 2 rows and 3 columns. Again, we will get 3 by 3. They are not equal. Their order is different. They cannot be equal. So here your answer will be equal to minus 10 to 21 minus 16. This is 10 minus 16 to 37 minus 2 minus 2 and 11. Okay. So clearly AB is not equal to B. So commutative property does not follow. One question you can note down. This is for your homework. This is question number 2. The 3 matrices A, B, C defined as A is equal to 1, 2 minus 1, 3 and D is equal to 4, 0, 1, 5 and C is equal to 2, 0, 1 minus. So first verify A into BC is equal to AB into C and second distributive property. Verify A into B plus C is equal to AB plus AC. That's all for today.